Mathematical Physics, Designing and Building a Roller Coaster. We will review the questions we asked the first thing in this unit, the questions about roller coasters. We will then review work and energy, and then we'll talk about designing and building a roller coaster. Questions about roller coasters. At the beginning of this unit, we built and observed a basic roller coaster. No, not this one. We built it out of some tubing. Our observations led us to some questions. Please go to the next slide and see if you can answer them now. Here were the questions. Number 1. A roller coaster needs to be moved to the top of the first hill to get started. What kind of effort is required? How much of this effort is needed? Number 2. Roller coasters move faster as they roll down and slower as they go up. When the coaster goes downhill, where does its speed come from? When the coaster goes uphill, where does its speed go? Please go to the next slide to check your answers after you think about this. Physics has a word for the effort to move a roller coaster to the top of a hill, or move any object for that matter. We call it work. And work is the force required to move any object times the distance it moves. Question 2. Where did the speed come from when it was going downhill? The speed came from gravitational potential energy transforming into kinetic energy. When the coaster goes uphill, where did that speed go? It goes into gravitational potential energy. Kinetic energy turns into gravitational potential energy. The reverse of the first answer there. 2 more questions. The higher a roller coaster starts, the faster it goes at the bottom. That's what hopefully we observed with our little roller coaster build. How can we predict the speed at the bottom knowing the starting height? Also, how can we predict how fast a coaster is going at any point on its track? Question 4. Roller coasters slow down as they move up. If a hill is too high, the coaster won't get to the top. How can we predict how high can a coaster go knowing its velocity? There's actually one answer to both of these questions. Think about it and go to the next slide when you're ready. The answer is conservation of energy. Whatever energy you start with, you wind up with the same amount of energy. Now, let's review what we know about work and energy.